Okay, so this time we're going to refer to amines. Amines are not necessarily mean, they just contain nitrogen. So if you want to consider nitrogen mean and that helps you remember how to do it, that would be fine. Here, this is the most common amine we refer to as ammonia. That is a common name, but it's kind of the IUPAC name as well. So you've seen this in several types of cleaners. Make sure that you don't combine ammonia with bleach because that can produce chlorine gas and kind of hurts you a little bit. This, on the other hand, is ammonium. Now, notably, the difference between the two is another hydrogen, and with that hydrogen comes this positive charge. So there's only 3 bonds that should be associated with ammonia, but once you have that 4th bond, this guy becomes a salt. And often as a salt, it will have a negative charge ion associated with it. Just like we saw with inorganic chemistry, hopefully. Okay, so let's name these guys. There tends to be a lot of naming when it comes to amines because there's just so many different variations. This, we just take the long chain, that would be 1, 2, 3, 4, so that would be butane. We remove the E, and since this has an amine in the end, we call it amine. So since this is on the first carbon of the butane, we don't have to designate that that's 1, although that's assumed. But this becomes butanamine. If it's on another position, we have to actually tell people where that nitrogen is located. So we have 1, 2, 3, 4, 5 carbons here. This would be on the second because that's the lowest number possible for that amine. And this becomes pentanamine. Other substituents may still be present. That's fine. This gets the lowest number, not these guys. So this becomes 2,4-dimethyl 3-hexanamine. Okay. Next, if you have some substituents that are coming off of the nitrogen, those do not count as part of the chain. This has still 1, 2, 3, 4 carbons in the long chain. This, however, is considered a substituent that comes off of that nitrogen. So when you go to name that substituent, you name it as normal, and its location is simply N. And that's capitalized and in italics most of the time. I can't really do that with my writing, but that's what it should be. So this becomes N-methyl butanamine. If you have more than one substituent, here we've got 2 methyls. We have to tell people where both of those methyls are, just like we did up here, right? We had to tell people where both this one was and this one. Same thing here. We have to tell people where both of those are. And that's the reason why we say N, N, dimethyl, and that's a propanamine. Here we have an N-ethyl, 1, 2, 3, 4, butanamine. There's only 1 there, so we only need to put the 1. Okay. Now, if there's another functional group, and usually these functional groups are going to contain oxygen, the NH2 is not going to be referred to as amine. We instead name the end of the word by the other functional group. Therefore, NH2 will become an amino substituent. So that's only if you have something usually with the oxygen. So that's an alcohol, there's an aldehyde, ketones will be in the same category, and here we have carboxylic acids. So here, this carboxylic acid takes priority and therefore gets the end of the word. So 1, 2, 3, 4, that's a butanoic acid, and we just named this in the beginning as a substituent, so it becomes 2-amino-butanoic acid. This would be number 1 because that's the end of the word. So 1, 2, 3, 4, 5 is pentanal, that's an al, sorry. So it becomes 4-amino pentanal. And here we have 1, 2, 3, 4, 5. That's a pentanol. The 2 is where the OH is. And this becomes 1, 2, 3, 4. So 4-amino, 2-pentanol. Aniline still exists. That hasn't gone anywhere. So remember, that's what aniline looks like right there. And that would be carbon number 1. And we number from there. So this becomes 3-methyl aniline. Or, as we did above, this becomes NN-dimethyl aniline. Okay, good. Now, we identify primary, secondary, and tertiary amines by what is directly attached to the nitrogen, unlike alcohols. Here, we have one carbon that's attached to that nitrogen. It doesn't matter what else is attached to that carbon. There's only one thing attached to that nitrogen. That's a primary amine. Secondary amine is going to have two carbons directly attached to that nitrogen, and a tertiary will have three. So that means that this guy has two hydrogens around a hydrogen bond. This has one, and this has none. And that's exactly the order in which you see the boiling point, or melting points, correspond to. So primary amines, since they can hydrogen bond more, are going to have the highest boiling point, melting point. Secondary amines, middle, and tertiary amines, the least. Because these can hydrogen bond the most, these can hydrogen bond the least. That also means that these are more soluble in water, and these are the least soluble in water. Secondary is just in the middle of all of that. Okay. Now, amines can act as slight bases in water. What that means is that they can accept a proton as base, right? So that means that they can take the hydrogen from water, and it can come over here. And in doing that, you're going to get a positive charge on that nitrogen. You're also going to get an OH minus. Now keep in mind, that is an equilibrium. Most of that stays over here. A little bit goes over there. Here's another way of looking at that. These electrons grab this hydrogen. And that's how I know that that positive charge exists and that negative charge exists. So when we have something like that with a positive charge in there, that's actually a quaternary nitrogen. So we refer to this as a quaternary ammonium salt. It's often that we see those used in medicines. And the easier way to do that is not in water, but in a strong acid. Because see how this is a direct reaction here? If I have an amine and I react it with a strong acid such as this, I end up with a positive charge here and a Cl minus right there. Okay, thank you very much.